All right, let's look at this example. Going back to the height of women in America. So for women age 18 and over in the Haynes 5 study, that's a government study about height of women in 2003. The mean was mu equals 63.5 inches. And the standard deviation was sigma equals 3 inches. Assume that the height of women is normally distributed, which is a pretty good assumption because evidence shows that's true. Is normally distributed. So what we're going to do is part A is we're going to convert to standard units. And we're going to use this formula. Z is the standard units, and I take X, which is the height of a woman, and we're going to subtract the mean, which is mu, and sigma, which is the standard deviation. So mu is, I already wrote, mu is 63.5 and sigma is 3. Okay, so start off with 66.5 inches. Let's just say X equals this. So our solution is we're just going to put this in the formula and write that X, or Z equals 66.5 minus 63.5 and divide by 3. And this gives us 3 divided by 3, which is 1. So if you wanted to draw the picture, here's 0, -1, and 1. So this is where this woman is. She's 1 standard deviation in the mean. Remember that 68% is between -1 and 1. So if you take 100% minus 68%, you get 32%. And so then if you take the 32% and divide by 2, you get 16%. And so it's not part of the problem, but I just wanted to point out how can we interpret this data is that 16% of the population is this woman's height or taller. And if you then say, well, 68% is taller, her height or taller, that means 84% of the population is her height or less. Okay, we didn't really need to do that, but I just wanted to point out, well, what should I do with that number? I mean, how can I think about that? So what? She's one standard unit. Well, you can look at it as percentages that are to the left of 1 or to the right of 1, and you can, then you make your, put together your thoughts about what you think is that person tall or not. I mean, especially at least Americans, we're used to talking about inches, but if you're presented with some other units, then what are you going to do with those? And I'll tell you what you're going to do is you're going to put them into standard units, and then with the standard units, we can look at that normal distribution curve and think of what's going on. Okay, so this person, 57.5 inches, we're going to find that person's height in standard units, not in inches. We're going to move to standard units. And we're going to see that that person is, well, we can already see that's below average. 57.5 is less than 63.5. And so when I subtract there, I think I can do that in my head and get -6 divided by 3. So it's -2 standard units. And again, I'm going to look at this picture here. Here's 0, -2, and 2. And I'm just going to, without really getting too much into it this time, that's 95% of the population is between -2 and 2 standard units. So then you can think about, okay, well, that person's, you know, that's where they are. 95%, they're on the edge of this 95%. So 95%, what's left over is 5%, divided that in half, that gives 2.5%. So they are taller than 2.5% of the population, but they're not as tall as 95 plus 2.5, which is 97.5. Okay, so then let's look at this next one, x equals 64 inches. And we'll just use the formula again. So this is going to be 64 minus 63.5 divided by 3. So this is 0.5 divided by 3. I can do this easier in my head if I write this as a fraction. And then that's about 0.167. For whatever reason, I rounded to 3 decimal places. So this one is pretty close to just right there in the middle. Just by looking at this curve, here's 68%. It's pretty close to average. 64 inches, a little bit above. I want to finish this and just fit this into this space without flipping the page. X equals 63 inches. So Z is X minus sigma, no, X minus mu over sigma. So this is 63 minus 63.5 over 3. So this is negative 0.5 over 3. So this is, if you put this in the calculator later, this is also pretty close to 0 standard units. Okay, so what were we doing? This whole thing was putting something in standard units. We're given inches, and you think, well, okay, I don't know, is that tall or not, or is that not very tall? Where should we put this in? Well, we're putting this in context of the population. I mean, what does it mean to be tall or short anyway? It's in relative to the population. In the United States, for women in 2003, the average height was 63.5. But that's not enough. The standard deviation is so important to say, well, you know, to answer the question of what does it mean to be tall. Standard deviation is important. So in this one right here, 66.5, we can tell, I know by not really taking any math class, 66.5 is greater than 63.5. But how much taller? It's 3 inches taller. That's 1 standard deviation. I put in the formula, I can find 1 standard deviation. By knowing the normal distribution curve, I can make a judgment about that, or a thought of like, oh, okay, well, 68% is between -1 and 1 standard deviation, or 1 standard unit. Okay, so then let's do one that might knock your socks off a little bit, but let's see what happens here. Let's look at B. So suppose the Z-score of a woman's height is Z equals -1.2. Okay, so that doesn't. Okay, so anyway, this could be men's height. Okay, so there's a bunch of examples of men's height. So this is a Z-score of -1.2. So what is the woman's height? Okay, so we have this information that was given. The mu was 63.5, sigma was equal to 3. And we have this formula. So the thing about this is perhaps going to require, not perhaps, I guess it's going to require us to use algebra here. So I'm going to plug into this formula. I get negative 1.2 equals x minus 63.5 over 3. And then what we can do is we can solve by multiplying both sides by 3. So this is going to be negative 3.6. And then we add 63.5 to both sides. And then I can try to do that in my head. And I believe that's 59.9. So, all right, so the thing is that if you're not really all that happy about doing this algebra on the fly, we can also write down a formula which is found by just doing the same algebra I showed here with numbers, but using it for those symbols. And if you do that, you can write that x is equal to mu plus sigma times z. So how would you get that? You multiply both sides by sigma, and so you're going to get sigma z, and then you add mu to both sides. So you can use that just as well. Then x would just equal 63.5 plus 3 times negative 1.2, and so we're going to get exactly the same thing that we had before. So you just, if you have this formula, I mean, why not use that formula since we have this formula that we memorize? Well, I mean, some people don't want to memorize more formulas. They want to just keep a few formulas in their heads and not memorize too much. But that's another formula. So we have these two formulas. So what's this formula here? This formula says if you know x, mu, sigma, you can find z. This says if you know z, mu, and sigma, you can find x.